In the second part of section 9.3, we are looking at what is called the instantaneous rate of change. As an introduction to this idea, we're going to talk about a couple of definitions and then use this picture. First of all, a secant line is a line that crosses a graph at exactly 2 points. A tangent line is a line that touches a graph at 1 point. So I want to look at, just sketching anywhere in here, a secant line. This is a secant line for this figure. If I look at this point on the left where my secant line is crossing the figure, I don't know exactly what those coordinates are, so I'm just going to call it x and f of x. Remember, f of x means what y value do you get if you plug that x value into the function. If I go over to the right-hand point, because I have moved to the right, this point is my original x plus some number that we don't know, so we're just going to call it x plus h. Then my y-coordinate, I have to put the x-coordinate into the function. So my y-coordinate would be f of x plus h. So those would be the two coordinates for those points. So let's think about, what if I kept the same left-hand point but went up a little bit? What if I did it again? Kept the same left-hand point but went up a little bit. Kept the same left-hand point but went up a little bit. What's happening to the h? The h is your right-hand distance, your right moving distance. Your y values are going up, that's fine. But if you think about what's happening to the x values, the h amount is getting smaller and smaller and smaller. So if we think about what would be happening if we had this line, the tangent line, what has happened then is we have let that h get as small as we can and let it approach 0. So if you think about, we could find slope of our secant. If we did slope of the secant, it would be y minus y, so we would have f of x plus h minus f of x over the x-coordinates were x plus h minus x, but that just simplifies to be f of x plus h minus f of x over h. So the slope for any one of those secant lines would be this formula. But the slope of the tangent line means that the h was getting smaller and smaller and smaller and approaching 0. So the slope of the tangent is the limit as h approaches 0 for the secant line. So we get f of x plus h minus f of x over h. This is the thing that we will be working with now, the slope of the tangent line formula. This idea is so important in calculus that it gets its own name, and this is called the definition of the derivative. If you are asked to solve a problem using the definition of the derivative, this is what you are doing. The various applications of the derivative that we will be looking at are finding the velocity of a function, finding the instantaneous rate of change of a function, finding the marginal revenue, marginal cost, or marginal profit for a function, or finding the slope of the tangent or slope of a function. If it says either one of those about slope, then you want to use the derivative. On example 3, we are asked to find the formula for the slope of the tangent to the function f of x equals x squared plus 2. Then we are to actually find the slope at x equals -1. So this is really two questions. As soon as you see find and find, it's two different things. The wording in here, as soon as you see slope of the tangent, as soon as you see this, this means that you need to find the derivative. We're going to break this into 4 separate steps. Some of you may have already taken calculus and done it differently. This is just the way that I have found works the best for the majority of my students. The first thing that you are going to do is find f of x plus h. Think about what that means. That means put x plus h into the function where x is. So in our function, the first thing we have is x squared. We're going to have to do x plus h squared. And then we have plus 2. Be really careful about this, ladies and gentlemen, because x plus h quantity squared means that you are doing x plus h times x plus h, and you have to do FOIL. If you do this, you get x squared plus 2xh plus h squared. You might as well memorize that because you're going to have to be able to do this. So continuing on then with finding f of x plus h, we will have x squared plus 2xh plus h squared plus 2. For step 2, the next thing that we do is find f of x plus h minus f of x. So what this is saying is take your answer from step 1, this is step 1, minus the original function. So for us, we need to take x squared plus 2xh plus h squared plus 2 and subtract the original function, which is x squared plus 2. The first parentheses aren't really doing anything, so we're just going to drop those. They were just separating which function is which. The second parentheses, we need to distribute our negative, so we get minus x squared minus 2. When you look at this result, you should see some items that will cancel each other. Notice we have x squared minus x squared, so those cancel. We have a positive 2 and a negative 2. Those cancel. And the only thing that's left is 2xh plus h squared. Notice that both of the terms that are left have h's in them. At the end of step 2, every term without an h must cancel. There are a few problems that you may run into where you actually have a term with an H that cancels, and that's okay. The thing that's important is every term without an H has to cancel. So now we're done with step 2. For step 3, we take f of x plus h minus f of x and put it over h. Well, if you think about what this numerator is, this part, that's step 2. So what we really need to do is put answer from step 2 over h. If I do that for this problem, I will have 2xh plus h squared over h. Notice that in the numerator we have h's in both terms, so if we factor out an h, the first term would be 2x and the second term would be just h now, and that's all over an h. But now h over h equals 1, we can take that out of there, and our final answer is 2x plus h. We are now ready for step 4. Step 4 is to do the limit as h approaches 0 of f of x plus h minus f of x all over h. But if you look at step 3, this thing is what we found the answer of for step 3. So for step 4, you do the limit as h approaches 0 to step 3. In this case, we would be doing the limit as h approaches 0 of the function that we got in step 3, which is 2x plus h. If you look at 2x plus h, that is polynomial in form. And when we have a polynomial, we just plug in our number. So now that we're plugging in our number, we stop writing limit and we do 2x plus 0, which just gives us 2x. So what's going on here is that we found the derivative. Our derivative is that answer. When we name derivatives, we take the letter from the name of our original function, which was f, we put an apostrophe after it, and we call it f prime of x, and that equals 2x. In this particular case, our application was slope of a tangent. So the 2x is, because it's a derivative, our formula for slope of a tangent. And that's what we were asked to find on question 1. So we are finally done with question 1. Now let's go to question 2. Question 2 said, find slope of the tangent at x equals -1. Well, that means that we need to put -1 into our derivative. F prime of -1 is going to be 2 times -1, which is -2. So that's our answer for question 2. Let's think a little bit about what we were doing in this problem. If we think about the original function of x squared plus 2, it is a parabola that is moved up 2 on the y-axis. So this is what we've got as the graph of our original function. This is x squared plus 2. What we found, if we go to what x value we were talking about the x value of -1, which is over here. If we were to go up to our function at -1 and draw the tangent line that meets the function right at -1, what we found then is the slope of that tangent line. And if you look at that line, it's going downhill, and so the slope should be negative. On example 4, our problem says the cost of producing x items is the function c of x equals 2,000 plus 40x plus x squared. Question 1 says find the marginal cost formula. Question 2 says find and interpret the marginal cost of 100 items. Look at question 1 and you see that it says find the marginal cost. That phrase is what tells you to find the derivative. We're going to do that 4-step process again. Step 1, we need to do, now in this case our function's name is c, so we're going to do c of x plus h. If we do that, we will get 2,000 plus 40 times x plus h plus x plus h that we are squaring. So doing that multiplying, we will get 2,000 plus 40x plus 40h plus x squared plus 2xh plus h squared. Take a look at those items, and none of them are like terms, so this whole big long thing is our answer for step 1. For step 2, we do c of x plus h minus c of x. So take the answer that we just got minus the original. So our first answer was 2,000 plus 40x plus 40h plus x squared plus 2xh plus h squared. Now we have to subtract the original function. If you subtract all those terms, you're going to change the sign of every term. So it will become minus 2,000 minus 40x minus x squared. Think back to what we said on our last example. Anything that does not have an h in it must cancel. My first term is 2,000. Do I have an opposite to cancel? Yes, I do. My next term is 40x. Do I have an opposite to cancel? Yes, I do. The next term is a 40h, and it does not have an opposite that cancels with it. The next item is positive x squared. Do I have an opposite? Yes, I do. My last two items are 2xh and h squared, which are h terms, so it's okay that they do not have opposites. They can be part of our answer. So our answer for step 2 is 40h plus 2xh plus h squared. And this will happen frequently, where you have a really long beginning of step 2, and then a whole bunch of stuff cancels, and you're left with something fairly simple. Now we go to step 3, where we take what we got in step 2, and we put that over h. Take the answer from step 2, that's what your numerator is. 40h plus 2xh plus h squared over h. Take one h out of every term, because that's what you have in the denominator is 1h. So you can take 1h out of every term. And if we do that, what's left is 40 plus 2x plus h. Now we're done with step 3. We're ready for step 4. Do the limit as h approaches 0 for the function c of x plus h minus c of x over h. In this problem, that just means that we are doing the limit as h approaches 0 of our answer from 3, 40 plus 2x plus h. And that's polynomial in form, so we're going to put 0 in for h. Remember, once you're subbing in, you stop writing limit. You're going to have 40 plus 2x plus 0, which gives you 40 plus 2x. Once you are done with step 4, that is now your derivative. This function's name was c, so this will be c prime of x, is the function 40 plus 2x. And in this case, the application that we are doing is marginal cost formula. When you get your derivative, it's always the formula for whatever the application is. In this case, it's marginal cost. That is now the answer to question 1. Question 2 said to find and interpret the marginal cost at 100. So what that means for us to do, first of all, if we are at 100 items, we need to do C prime of 100. C prime for 100 will be 40 plus 2 times 100. So 200 plus 40 gives you 240. This is a cost, so this is dollars. So there's the answer part, the number part for this. The other thing that we are supposed to do is interpret this. When you get an answer for a marginal cost or a marginal profit or a marginal revenue, this tells you how much it takes to produce the next item. So what we're going to say here is that cost increases $240 when changing from 100 to 101 items. So this, when you get your derivative, it's always telling you how we are changing at that number. So we are changing by $240. The total cost is not $240. The cost goes up by $240 when we switch from 100 to 101.